Hello and welcome to this webinar on the BM2 programming unit, in which we will be looking at standard settings for heating circuits and heating curve settings. Let's start by looking at the valve control unit. On the left you can see a BM2 programming unit and on the right a display module. Appliances must be fitted with a display module if the programming unit is used as a wall-mounted remote control or in cascade systems. In this connection, please note that heating appliance parameters can only be called up on the appliance itself. Visually, the two modules are differentiated by the 4 printed quick start keys. These are only printed on the display module. In addition, the display module has a black-white screen and the programming unit has a color screen. These are the most obvious differences to begin with. Now let's look more closely at the display module. At the top you can see the status display and at the bottom the different functions. In this case, the heating appliance is in domestic hot water. The 4 printed quick start keys are on the left. Push button 1 changes the set temperature of the heating appliance. However, this push button is deactivated if the BM2 programming unit is used as a wall-mounted remote control or in cascade systems. Push button 2 changes the set temperature of the domestic hot water. Here too, the push button is deactivated if the BM2 programming unit is used as a wall-mounted remote control or in cascade systems. Push button 3 activates emission test mode for 15 minutes, and push button 4 is used for acknowledging faults. The rotary selector with push button function is located on the right. This, in combination with the quick start keys, enables operation of the display module. Let's take a look at the BM2 programming unit. This also has 4 quick start buttons on the left-hand side. However, due to the fact that the programming unit offers more functions, these are not printed. The rotary selector with push button function, which we have already seen on the display module, is located on the right. It's immediately obvious that there is significantly more information on the screen. Operating mode, page heading, status display, system pressure display, date, time, whether an eBus link is available or not, and here you can see the function display for the quick start keys, which varies. Before we move on to the settings, I would like to go through a few questions concerning the heating curve. What is the function of the heating curve? Briefly, the heating curve specifies the flow temperature required to supply the selected radiators or the area heating system, for example, underfloor heating, in the building with the amount of energy required to heat them to the selected set temperature. Why is it important to get the settings right? Because this leads to lower fuel consumption, optimized runtimes, reduced wear, and increased efficiency. Aren't thermostatic valves adequate? No, this only changes the throughput. Having said that, the throughput should ideally match the system size and the flow temperature should be adjusted accordingly. The lower the flow temperature, the better. This brings us to condensing technology. Recommended flow temperatures for the optimal utilization of condensing technology are less than 60 degrees for gas and less than 55 degrees for oil. What is the night reduction setting option? Outside the program time programs, the heating appliance immediately switches into night setback. The flow temperature in economy mode, setback mode, and in night reduction is determined using the previously set heating curve. The temperature selection -4 to +4 and the economy factor 0 to 10. The economy factor can be set as follows. Press the rotary selector to open the main menu. Turn the rotary selector until basic settings is displayed. Select this option by pressing the rotary selector again. The heating circuit is then displayed. Press the rotary selector once again to select it. Now select the economy factor and open it by pressing the rotary selector. The value can now be adjusted by turning and pressing the rotary selector. The value is confirmed by pressing the rotary selector. The heating curve is either increased or reduced by means of temperature selection from -4 to +4. To change the temperature selection, turn the rotary selector until the heating circuit appears in the upper section. The thermometer symbol appears on the left-hand side. Select this with the relevant Quick Start key. You can now adjust the temperature. Pressing the button again applies the value. By how many Kelvin is the heating curve now reduced? We'll take the value of 5, which we just set for the economy factor. In this example, the low end temperature of 28 degrees is subtracted from the maximum flow temperature of 40 degrees. This gives us 12. Divide this by 10, as determined by the calculation formula, and the result is 1.2. Now multiply this by the economy factor 5, which we just selected. The heating curve is reduced by 6 Kelvin. Please note that for each reduction, the resulting heat loss has to be offset. How does economy mode work? As soon as economy mode is activated, the heating appliance operates in setback mode continuously. This has to be deactivated before the heating appliance can switch out of this operating condition. Economy mode is activated by turning the rotary selector until the heating circuit is reached. On the left, the rotary selector icon appears and is selected with the relevant Quick Start key. You can now select economy mode by means of the rotary selector and confirm by pressing it. If automatic mode is then required instead of economy mode, for example, this is set using the same procedure as before the economy mode. This automatically deactivates economy mode. Please note that here too, the heating appliance has to offset the heat loss. The setback mode setting option also defined as holiday mode. It's a single time, limited time, reduced mode. To activate this mode of operation, turn the rotary selector to the heating circuit. Once again, select the rotary selector icon with the Quick Start keys. Using the rotary selector, select setback mode. Program the times and press to confirm. Temporary setback mode is now indicated on the display. Please note that heat loss has to be offset here as well. Now let's take a look at the EQABS function. This function is only enabled if an outside sensor is connected. The setting range is between -10 degrees to 40 degrees. The Wolf factory setting is 10 degrees. If the average outside temperature is above the eco-ABS temperature, the heating and mixer circuit switches to standby mode when the appliance is in economy mode, setback mode, or night setback. If this value is below the eco-ABS temperature, the heating appliance reverts to the previous operating condition. To set the eco-ABS value, press the rotary selector. The main menu opens. Turn to Standard Settings and press the rotary selector. Select the heating circuit and press the rotary selector once more. As you can see, eco-ABS is displayed immediately. Turn to eco-ABS and confirm with the rotary selector. You can then change the values by turning the rotary selector. Confirm the new value by pressing the rotary selector once again. Why do we need a setback stop? The BM2 programming unit switches the heating appliance from economy mode, setback mode, and night reduction into heating mode if the average outside temperature falls below the set value. The setting range is between -30 degrees and 0 degree. The setback stop is also set via the main menu, which is opened by pressing the rotary selector. By turning and pressing the selector, you can reach the contractor level. You are now prompted to enter the contractor code, which is 4 times the number 1. In the contractor level, select the system and press the rotary selector. All system parameters are now shown. Turn the rotary selector until A12 setback stop appears. The value can now be changed by turning the rotary selector. Press again to apply the value. How does the winter-summer changeover work? The winter-summer changeover function is only enabled if an outside sensor is connected. This function optimizes the times when the system operates in heating mode. The setting range is between 0 degree to 40 degree. The Wolf factory setting is 20 degree. If the average outside temperature is above the set winter-summer temperature, the heating appliance switches to standby mode. If the value is below the set winter-summer temperature, the heating appliance switches to automatic timer mode. To change the factory setting of 20 degree, return to the main menu by pressing the rotary selector. Turn to the standard settings and confirm. Select the heating circuit and press the rotary selector again to confirm. The winter-summer changeover is now displayed. Select this by turning the rotary selector. Then change the value. Press once more to confirm the value. Let's have a look at how to set the heating curve on the BM2 programming unit. Pressing the rotary selector once opens the main menu. Turning the rotary selector takes us to the contractor level. The contractor level is opened by pressing the rotary selector again. This is where the contractor code has to be entered. The code is 1111. In this example, we are looking at the heating circuit. Please select the heating circuit and then the heating curves. 4 values are now requested, which must be set to match the application. To begin with, the low-end temperature. This is the lowest flow temperature in heating mode. Then there is the heating curve starting point. This is the point at which the flow temperature is increased slowly depending on the outside temperature. The standard outside temperature is defined in a European standard. The standard outside temperature is the lowest average temperature over 2 days that is reached or undershot 10 times in 20 years. And last but not least, the maximum flow temperature at the standard outside temperature. The heating area is sized according to this value. Let's start with the low end temperature. The required low end temperature is set by turning the rotary selector, visible here in the upper section. Press it to apply the set temperature. For underfloor heating, we recommend a temperature of approximately 28 degrees. It is advisable to select a higher temperature of approximately 35 degrees for radiators. As soon as this temperature is confirmed by pressing the rotary selector once more, the next setting option appears automatically. This brings us to the setting option for the standard outside temperature. I'm taking the Munich area for this, which is -16 degrees. This is confirmed just like the low end temperature by turning and pressing the rotary selector. The next setting option is the heating curve starting point. It is advisable to set this to approximately 12 degrees for new builds. For older buildings, we recommend approximately 15 degrees. Finally, we set the maximum flow temperature. We recommend 40 degrees for underfloor heating or area heating. However, this is dependent on the particular underfloor or area heating system. For radiators, the maximum flow temperature should be raised to 65 degrees. This is also depends on the particular radiator. Now the heating curve has been set correctly. The following valve factory settings are stored. Flow temperature 30 degrees. Heating curve starting point 20 degrees. Standard outside temperature -16 degrees. And a maximum flow temperature of 65 degrees. Factory settings always should be changed and adapted individually to the system. Here you can see a sample heating curve setting for a new build with underfloor heating or area heating. This shows a low end temperature of 28 degrees and a heating curve starting point which is set to 12 degrees. The standard outside temperature is -16 degrees and the maximum flow temperature is 40 degrees. Now let's take a look at the heating curve setting for an older building with radiators. We have a low end temperature of 35 degrees and a heating curve starting point of 15 degrees. The standard outside temperature is again -16 degrees and the maximum flow temperature is 65 degrees. Here are the adjusted heating curves once more, enabling a direct comparison between radiators and area heating. It's immediately obvious that the gradient is lower in the case of area heating. Here you can also see when the heating appliance starts up. This depends on the winter-summer changeover. The value is just over 20 degrees. Apart from that, we can see our set values, the low end temperature, the heating curve starting point, and the maximum flow temperature at a standard outside temperature of -16 degrees. Here you can see a heating curve in red and the corresponding setback mode in blue. The winter-summer changeover is defined at 20 degrees in this example. Outside the scheduled time programs, the heating appliance in this example switches to setback mode at temperatures below 10 degrees. Above 10 degrees, the appliance switches to standby mode. This means that ECO ABS is programmed at 10 degrees. You can see that the setback stop in the upper right hand section. This is programmed at -10 degrees. If the temperature falls below this, the heating appliance switches from setback mode to heating mode. In this example, setback mode operates between 10 and -10 degrees. How can these settings be corrected if this becomes necessary? A parallel offset of the heating curve can be performed by changing the low end temperature and the maximum flow temperature. If it's continuously too cold, increase the low end temperature and the maximum flow temperature. If it's continuously too warm, decrease the low end temperature and the maximum flow temperature. If it's only too cold at low outside temperatures, increase the maximum flow temperature only. If it's only too warm at low outside temperatures, decrease the maximum flow temperature. In this way, the heating curve can be optimized. If it's only too cold by outside temperatures between plus 15 degrees and 0 degrees, increase the low end temperature. If it's only too warm by outside temperatures between plus 15 and 0 degrees, decrease the low end temperature. Yeah, that's it. Thank you for your attention and have a good time.